Hi, Assalamualaikum. My name is Nurul Anis binti Muhammad Amin. I'm from DKM2B Section 3. My metric numbers is 14 DKM20F2053.
Assalamualaikum to Puan Zarina and friends. My name is Nur Shahira binti Harun from DKM2B Section 3. My metric number is 14 DKM 20F 2051.
Assalamualaikum and good and hello to everyone. My name is Siti Noraisha binti Azlan. My metric number is 14 DKM 20F 2045, 14 DKM 20F 2045. Introduction for the topic. Introduction for minimum, maximum, or inflection point. Stationary point is a point on the function graph where the gradient of the function is 0. Turning point is when the gradient of the function changes sign at the stationary point. It can be a local maximum or local minimum. If the gradient of the function changes sign at a stationary point, it is called a turning point. It can be a local maximum or a local minimum. If the gradient of the function does not change signs at the stationary point, then it is a point of horizontal inflection. Stationary on a curve occurs when dy over dx equals 0. Once you have established where there is stationary point, the type of stationary point, which is maximum, minimum, or point of inflection, can be determined using the second derivative. Differentiation, which is like if d square y over dx is bigger than 0 is positive, then it is minimum point. If dy square y if d square y over dx is smaller than 0 is negative, then it is maximum point. If d square y over dx equals 0, then it is point of inflection. Step of solving problem of maximum, minimum, or inflection point is step 1 to differentiate the function given, which is y equal f in bracket x. Step 2 is to find the value of x when dy over dx equals 0. Step 3, substitute the value of x in f in bracket x. Step 4, to write in coordinate x, y of turning point. Step 5, use the second derivative d square y over dx to find the maximum, minimum, or inflection point. Step 6 is to write the coordinate xy of maximum, minimum, or inflection point. And step 7, the last step, is to sketch the graph. Question for the topic maximum, minimum, or inflection point is for the following questions below. Determine the stationary point, whether it is maximum, minimum, or inflection point. The first question is to determine the stationary point for y equals 2 plus 3x squared minus x squared 3, if it is maximum, minimum, or inflection point.
Okay, the question is y is equal to 2 plus 3x squared minus 5x cubed. Indeed, the formula for differentiation is dy over by dx is equal to 0. when we then differentiate, we will get 6x minus by 3x squared is equal to 0. 6x minus by 3x squared, we factorize it, we will get 3x bracket 2 minus x is equal to 0. When we want to find x, we must separate 3x and 2 minus x. When we separate, 3x is equal to 0, 2 minus x is equal to 0. When we simplify, we will get x is equal to 0 and x is equal to 2. When x is equal to 0, we use the initial differentiate. We will which is 2 plus 3x squared minus 5x cubed. Okay, y is equal to 2 plus 3 bracket 0. We put 0 into x. 3 bracket 0 square minus by bracket 0 cube. When we simplify it using calculator, we will get 2. Okay, when x is equal to 2, using initial differentiate, which is y is equal to 2 plus 3x squared minus by x cube, put it 2 into x, which is 2 plus 3 bracket 2 square minus by bracket 2 cube. When we simplify, we will get 6. And then using formula d square y over by dx square is equal to d over by dx bracket 6x minus by 3x square. When we then differentiate it again, we will get 6 minus by 6x. Add to 6, d square y over by dx square is equal to 6 minus by 6 bracket 2. Put 2 into x, which is 2 is x and 6 is y. When we simplify, we will get negative 6. Negative 6 is smaller than 0. When the value is smaller than 0, the answer must be maximum point. And then add 0 to 0 is x and y is 2. Using formula d square y over by dx square is equal to 6 minus by 6 bracket 0. Put it 0 into x. Okay, 6, the answer is 6. So 6 is greater than 0, right? So the answer must be minimum point. When the value is greater than 0, the answer must be minimum point. This is how we want to find maximum and minimum point in the graph. So we mark 0 to, then mark to 6. After mark the graph at 0 to, it will go down and then go up at the graph to 6. So this is the graph for equation y is equal to 2 plus 3x squared minus 5x cubed.
Introduction. The gradient function dy over dx of a curve measures the rate at which the curve increases or decreases. If y equal f bracket x, so dy over dx is a rate of change y respect to x. Chain rule method used to express the rate of change dy over dx equal dy over dt multiply dt over dx. It is related with parametric equation. The positive value for dy over dx, the rate of increases for y respect to x. The negative value for dy over dx, the rate of decreases y respect to x.
Okay, the question for the rate of changes is the volume of sphere is increasing at a constant rate 12.5 cm3. Find the radius of the sphere at the instant when the radius is increasing at a rate of 0.2 cm. Okay, the volume of sphere is 4 over 3 pi r cubed. Okay, what we get from this question is dr over dt is equal to 0.2 and dv over by dt is equal to 12.8 pi.
Solution. Here solution for the question below. So the formula is dv over dt equal dv over dr multiply dr over dt. dv over dt is 12.8 pi equal dv over dr is bracket 4 over 3 3 pi r square. Multiply dr over dt is 0.2 and remove 3 from dv over dr. Become 12.8 pi equal 4 pi r square. Multiply 0.2. Bring 4 pi r square to the left side and it becomes 12.8 pi over 4 pi r square equals 0.2. Bring 12.8 pi over 0.2 multiply 4 pi to the right side. It will become r square equals 12.8 pi over 0.2 multiply 4 pi, and after that remove pi. Become r square equals 12.8 over 0.8. And then replace r square with square root, become square root r square. 12.8 over 0.8 becomes square root 16. So the answer is r equal 4 cm. So that's all from us. Thank you.